Hello, so I'm live. It takes a while to get live, but I am live now. So, last discussion we had, we discussed about the basics of data sufficiency, and we'll be continuing the problems from there, where the 25 most important DS questions to understand all types of DS drafts. So this was the first question where we solved. It was a little bit tricky, but we understood how basic DS operates. So this was the first question that we solved. Today we'll be continuing on that and we'll solve the remaining questions. So we'll take breaks in between. If the video gets too long, live stream gets too long, we'll take that. So right now we'll start with number two. So question number two says, if y is greater than equal to 0, this means y is positive or 0. I am considering 0 as positive in this case. And then what is the value of x? So basically there are two types of questions. There is an is or does kind of questions, which starts with is the value of x 2 and or is the value of x 100. So these kinds of things. So for these, you will always get a yes or no answer based on uh, yeah, yes or no based on what kind of option it is. So uh, if if it is a yes for all values or a no for all values, you get a sufficient answer. And if not, if you get yes and no for a single uh, what do you need to say, single option one and two, then you mark it as not sufficient, and you mark A, B, C, or D based on that. The next kind of questions is the what type of questions. Whenever there is a what type of question, you should have a particular value. So if this value is in for all the possible cases, then we get a sufficient answer. If it is different, if it is not unique, then you say it is uh, unique. Okay, so then it is not sufficient. Right. So saying taking the same approach, we'll be solving this question. Mm, This is a what type of question. In this, we will see the first element is yeah, mod of 3, mod of x minus 3 is greater than or equal to y. So in this case, y is given as positive. So what will happen since this guy is positive, and this will always be positive since mods are always positive. So any positive value greater than or equal to a positive value is always positive. All right. So what do you can you get a unique value of x in this? I don't think so, because suppose we take y is equal to 0, then x could be 3 minus 3, right? But since it is a greater than sign, so for even y is equal to 0, we can get 4 minus x is equal to 4, and this guy becomes 4 minus 3, which is actually greater than 0. So already we got two values, which is enough to say this is not sufficient. Next condition that it is given is x minus 3 is a minus sign, x minus 3 mod, right? This can, since it's a positive value, anything less than 0 is negative value. But one more thing, it could be also 0. So 0 is equal to 0 is a possibility. So there is only one condition, x minus 3 mod equal to 0, which satisfies this equation. So that makes x is equal to 3 every time. So this is one condition that is always fulfilled. Now we will check this solution, how actually they have solved it. Yeah. So the second question, the solution says y can have any value. Suppose y is equal to 1, 2, 3. Okay, so they have solved it like this. What they have done is basically they have taken a value of y like 1, and then they have put back it in the equation like x minus 3 mod is equal to 1, and then they have solved for x and got one value. Similar to that, again, they have taken another value of y, solved for this equation and got another value. So basically, that's how they are doing. What we did is we took one particular value of y, and for that we just saw that whether that equation satisfies the a different value of x in that case. So right, we also got it in one of the methods, which is also right. Their method is also right. Let's take the second condition. The second condition says x minus 3 mod is less than equal to y, and since x is positive, this becomes negative. So what they say, we take y as positive. We can't take y as positive. Yeah, so they can't take y as positive because this will become negative, and mod of x minus 3 will become negative. So the only value y can be 0. So they also say that this is an invalid condition, kind of in a more easier language, where uh, now they say that when y is equal to 0, uh, then again x minus 3 can not be less than 0 by the definition of mod. So the only value of x minus 3 can be 0. So mod of x minus 3 is equal to 0. So x will have a unique value x equal to 3. So this is correct. So basically we have got it correct, and the answer is always B, because this is not sufficient and is sufficient, right? Okay, so I think that is easy, because it's an easy problem. Let's see next problem. Problem number 3 is, on the number line shown is 0 halfway between R and S. So there is a number line that is shown which says R, S, and T. So the number line is just having nothing else but a sequence. So there is a sequence of R, S, and T. So it will always follow the sequence. There will be no difference in the sequence. Then the condition that is given is S is right to 0. S is right to 0. That means S is positive. And let's see whether this condition is sufficient to say that 0 is halfway. That means we want to check whether 0 lies here and R to 0 is equal to 0 to S. If we analyze, it could only happen when R is equal to minus S, right? Or it could happen if, um, how it can happen, or if it is opposite, like if um, if the setup is something like here it is R, uh, okay, and S is somewhere here, I guess. No, still will not have that. Um, how we can have that is, yeah, maybe there could be situation. I think this is the only situation, looks like, because if it has to be halfway, then in that case, right side of t could only be on the left side of t. Now 0 could be on the right side of t, 0 could be on the left side of t, or anywhere. So basically we need to find where is 0. So this is distance is equal to distance between t and minus s. So if s is here, minus s could be uh, minus s has to be on the other side of 0. So if 0 is somewhere on this side, suppose 0 is here, then minus s is here, and this distance is equal to this distance. This is one condition. So in this condition, 0 is not in between R and S. The other condition would be here. Again, we say R, S, and T. Now, in this condition, they say that 0 is here, and the distance between R and minus S. Minus S should be on the left hand side. So since R is minus S has to be on the left hand side, it always has to be symmetrical, because this should be equal to this, because 0 S is 0 and minus S is 0. And again, this distance, okay, in this condition also, this distance has to be equal to this distance, which is possible, right? Like suppose if this is 2 and this becomes minus 2 or something like that. And yeah, if this is 2 and this is minus 2, this has to be 0. And the distance of t minus s, and suppose this guy is 1, then, okay, sorry, this is 2 and this is minus 2, obviously. Yeah. So this is 1, and this guy is already more. So this distance is not equal to this distance in my example. So basically, we have to take a bigger value. What we can say is we can take something like 4, minus 4 and 4. So distance between this is 3, and here it has to be the 1, then minus 1. So it basically has to be 4. So it has to be minus 3. So this guy, this is minus 3. Since s is minus 4, it will be somewhere here. This will be s minus 4. Yeah, so let me clear it up. So this will be something like this in that case, like this. So minus s is equal to 4 here. So s will be equal to minus 4 here. R is equal to minus 3 here. Distance between R and T is 4. Distance between T, okay, this has to be minus 2, right? Yeah, distance between R is equal to minus 2. Distance between, this is 3. Distance between T and S is 3. So basically, we can get that. So this is also possible. So obviously, this we are basically getting two solutions. This is not sufficient. Okay, so I think, yeah. So the third thing that we can do is we can basically combine. So this guy says S is positive, which is the first condition. So if S is positive, S is positive, then in this condition S is negative. In this condition S is positive. So in this case it lies. We get a yes answer here, and this we are getting no answer here. So it is, so this condition is discarded if we consider the first one. So with uh, with both the condition we get like C answer, which is right. Okay, let's see how they have solved it. So they are plugging in the numbers again instead of like drawing. What they say is if line reads r is equal to 1, 0, um, yeah, so it's almost the same solution. It looks like, let's draw what they want. They say that if the line, this is the line, if it reads minus 1, 0, 1, and 3, so this is basically r, s, and t, then 0